Hello everyone. Today we're going to discuss about graphical user interface. So what is graphical user interface? A graphical user interface is an interface that allows users to interact with electronic devices through graphical elements such as icons, buttons, and windows. GUIs are designed to make it easier for users to interact with complex software and hardware systems. So it is a type of user interface that allows users to interact with electronic devices and software applications through graphical elements. And the evolution of graphical user interface, the graphical user interfaces have come a long way since their inception in the 1970s. Early GUIs were primitive by today's standards, with limited graphics and simple functionality. However, advancements in technology have allowed for more sophisticated GUIs with advanced graphics, animations, and interactive. The design principles: consistency, simplicity, and clarity. So, the consistency: maintaining a consistent design throughout the interface helps user easily understand and navigate the system. Simplicity: a clean and simple design reduces cognitive load and makes the interface more intuitive to use. Clarity: clear and concise labeling, messaging, and feedback help users understand the system and complete tasks efficiently. Layout and navigation. The layout of the GUI is crucial in determining how the user interacts with the system. It should be intuitive, easy to navigate, and visually appealing. A well-designed layout can enhance the user experience and increase productivity by reducing the time it takes to complete tasks. Navigation. Navigation is an essential aspect of a GUI design. So the navigation should be clear and consistent throughout the system. The user should be able to easily move from one section to another without getting lost or confused. The use of breadcrumbs, menus, and icons can help improve navigation and make it more efficient. Color and typography. Choosing the right color palette and typography can greatly enhance the user experience. Interactive and feedback. User feedback. Design your GUI to provide user with feedback on their actions. This can include feedback on form validation, successful completion of a task, and error messages. Feedback should be clear and easy to understand, helping users to feel confident in their interactions with your GUI. And then interactive. Interactive is a key aspect of GUI design. Users expect to be able to interact with your GUI in meaningful ways. This can include features like drag and drop, clickable buttons, and sliders. Ensures that your GUI is designed to be intuitive and responsive to user interaction. Now let's see the example using Android Studio. So here I've opened the Android Studio and I've designed the dashboard of SVC college app. So this XML code appears to define the layout of an Android app screen. It is used for the user interface of an Android application. So now let's break down the code and explain its component. XML version encoding UTF-8. So this line indicates that the file is a XML document with version 1 and encoded in UTF-8. And then scroll view. This is the root element of the layout and represents a scrollable view. It allows the users to scroll through the content if it doesn't fit on the entirely on the screen. As you can see here, it will scroll. XML Android, XML app, and XML tools. These attributes define XML namespaces for various attributes used within the layout file. So they are used to specify the namespace for Android attributes, app specific attributes, and development tool attributes. And then Android layout width and Android layout height. So these attributes set the width and height of the scroll view to match your parent um, and the wrap content respectively. This means the scroll view will fill the parent's width and adjust its height based on the content. Tools context. So this attribute specifies the context or activity associated with this layout, which is set to dot dashboard activity. Inside the scroll view, we have the constraint layout. So Android layout width, layout height. So these attributes also set the width and height of the constraint layout to match parent and wrap content respectively. And then Android ID, this attribute assigns an ID to the constraint layout, which can be used to reference it in a Java code. So then Android layout margin top. So this attribute adds a margin of 20 dp from the top of the layout. So inside the constraint layout, there are several child views, including text views, image view, and card views, organized in rows and columns using linear layout. So the text view displays text and image view displays images. Card views provide a material design card-like appearance to the content within them. So relative layouts are used within card views to arrange text views and image views within each card. So these child views are organized into row 1, row 2, row 5. Yeah. So this is set to row 1, this is set to row 2, and then this is set to row 3, and then this is set to row 4, and so on. So each card view contains a relative layout to arrange its child view, a text view displaying a title, example, profile, attendance, etc. An image view displaying an associated image. So various attributes are set for each of these images, including dimensions, margins, text colors, and images. Overall, the layout appears to represent a dashboard screen with multiple cards, each representing a different category or a feature of an app, such as profile, attendance, academics, fees payment, e-learning, activities, facilities, and written feedback. Users can scroll vertically through the content if it doesn't fit on the screen due to the enclosing scroll view. So this XML layout is a visual representation of the user interface for a dashboard screen in an Android app. So and it uses constraint layout to organize and position various elements. And that's it. Thanks.